Bharat Lohani and I am professor in IIT Kanpur. In this presentation, I am going to talk about the LiDAR technology and its use in various projects, especially related to the construction. So I will be using the data and the examples which have been done by a company Juno, which I founded in IIT Kanpur, and now this company is operating from Hyderabad and Delhi. So that's why you will find the Juno logo also there. So we know in any project, there are a couple of stages. For example, there is a planning stage, there is execution stage, there is operation stage. And in all these three stages, we need very good quality measurement of the project site. In planning stage, we needed to plan the project. So we need the topographic maps. In execution stage also, we need to monitor the construction, how the construction is progressing. So again, at that time, we need the topographic data. And in operation stage, we want to know the health of the project. So at that time also, we need to map the project in some manner. So for all these, we need a mapping technology, and because of the modern requirement of quality, of speed, the technology that we use should be fast, it should be accurate, it should be reliable, okay, it should be comprehensive. When I say comprehensive, I mean once I operate in that area, map that area with the technology, I should be able to map everything. There should not be any confusion. I need not to go to the ground again and again. Okay. Finally, the method should be cost effective. So, if we look at the technologies, and there is a couple of technologies. Traditionally we have been using the total station and the GNSS. So here is the total station GNSS or the photogrammetry or the satellite, and now the new technology of LiDAR. So if we compare these technologies on certain parameters, and when I say parameters, I mean accuracy, speed, completeness, comprehensiveness, and ease, cost effectiveness, then possibility of doing the technology even in remote areas. So in all these cases, if we compare the technologies, you will find the LiDAR technology compares the best with respect to the other technologies. Okay, so here red means poor, green means very good. So what is this technology? That in this technology, we are using a laser pulse which is being transmitted this way, and this laser pulse will come back. So we will be able to measure the time of travel. From this, we know the distance between these 2 points. Well, if we know the distance, the same instrument is now being carried along with a GPS, an orientation sensor. So that's the scanner where the laser is being fired and is being scanned. So that way, this laser will fire its pulses everywhere on the ground, and as we just said, with the help of GPS and the distance measurement here, it is possible for us to compute the coordinates of the point in the ground, say x, y, g. So for all these points, we'll have the x, y, g coordinates. The way the technology works, say in case of an airborne case, here we have an aircraft, and in the aircraft we have kept the laser scanner. So wherever the laser is hitting the ground, we will be able to generate a coordinate there. So x, y, g. So as we fly with some processes, then we have the coordinates of the point in the ground. And you will notice here, we are able to fire some 500,000 pulses every second. That means a very dense data is being produced. So whatever is there on the ground, that is being mapped. Even the transmission lines can be mapped. What this data will look like? So here is one example. As I said, it's a very comprehensive data, and you will notice this image which I am showing you is in fact made of the coordinates. So wherever there is a point, that means for that point I know is xyz coordinates. So I know the xyz coordinates of all these points along with the points here on the ground. So quite comprehensive data, and with this data, once the coordinates are there, I can now determine the height of the tree, I can determine the slope of the ground, and so on. All the measurements can be done. So the way the technology works, I carry out the measurements in the field, bring this data into my office, and then in office we carry out these measurements sitting in front of the computer. So that is also, we call armchair surveying nowadays. So we can do one more thing. We can keep this instrument in a car. Okay, now here is the instrument, the same LiDAR instrument on a car, and as the car is going along the road, whatever is there in the surrounding, that can be mapped. So you will notice here also we have for each of these points the XYZ coordinates. So with the help of this, I can measure the height, the width of the median, I can measure the height of the pole, I can measure the diameter of the tree, I can measure the canopy diameter of the tree, and I can measure what is the canopy volume and the slope on the ground, and so on. All these measurements can be done now sitting in the office. So if we compare these two technologies, LiDAR technology is much superior than the traditional technology, and I'm writing these comparisons only here. One more advantage of this technology is, unlike in case of satellite data or photogrammetry, in case of satellite data, you are taking the images from satellite, or in photogrammetry, you are taking camera images from the aircraft or the drone. What you see only the top of the trees, as in this case. So there is no data of the ground. However, laser can penetrate through the trees, and you can generate the data of the ground, and with some algorithms it is possible that we can map the ground still in much more detail, which otherwise is not possible in other technologies. In this kind of the area where this is a dense forest, even I cannot map with the GPS, or I cannot map with the total station, but LiDAR technology is able to give me a very good quality map or contours of that area. So what we get out of this? We get, I like to call it this way, a 3D Xerox of the ground. Three-dimensional Xerox means it's the true copy, and now once the mapping has been done in the field, the data is in my computer, and whatever planning I have to do, I can do that planning in my computer. Okay, so you will notice here that what all the features of the ground, whether they are the boundaries of the plots, or whether they are the small bushes or the hedges or the trees or the houses here, everything has been mapped by the LiDAR. Along with the LiDAR, we also fly, or in the car also we keep a camera, and the camera is able to give you a very good visual information about the terrain. So for example, here the resolution of the camera is so good, you can see very small objects also there on the ground. Now with this kind of the information, it is very easy for us to plan the project. For example, if you are planning the project, say high-speed rail corridor where this data was used, the project can be planned now by looking at the images, by looking at the 3D data, and sitting in the office itself, we can plan the project quite well. Okay, and the requirements of going to the field again and again can be reduced, and this has been also observed in the Mumbai Ahmedabad high-speed rail corridor project that we had done. So from the data you can generate digital elevation model, which is again yes required for the planning, and then contours, which is simple. We have also the ortho photograph. So ortho photograph is just like map. You can carry out the measurements on this. For example, if you want to measure this distance, you can measure the distance on the ortho photograph, because its characteristic is of map, but visually it is photograph. So very good data product for any planning. Okay. Finally, because in our projects we need many layers, whether in AutoCAD or in GIS, all these layers of the information can also be created from the LiDAR data and the photograph. So this is an example of the layers which were generated for bullet train. Alright, so what are the studies, case studies? So instead of talking of what can be done, I will show you what has been done. So in India, the technology has been used in many railway projects for their FLS survey. So this is the example for the high-speed rail corridor. The technology has been used for many highway projects. So this is a very special example when in Mizoram the terrain is highly wooded and undulating. So it was not possible to carry out traditional surveys. But the LiDAR data provided a very good digital elevation model, and using that the various DPRs were generated or the corridor were planned. Then yes, the data can be used for disaster management, for the flood monitoring, for the landslide and so on. The data is used also for the irrigation, and there is a very interesting project in Godavari, on Godavari river, where the data was used. Similarly, for river interlinking, we need the undulations of the ground, so there also the data has been used. The technology has been used also for river interlinking in Rajasthan. Okay, the project details are given over here. And also for carrying water from Jhunjhunu to Haryana, from Haryana, Tejawala to Jhunjhunu, again this entire area was mapped with the technology. Yes, for the micro lift irrigation also the technology can be used, and this is the case study, and all these projects have already been done and many similar projects have been done. Similarly, the technology can be used for forest mapping. So in a project area wherever you have got a forest, while you map the area, you have also the information about how many trees are there, what is the size and shape of the trees. So very important for the environmental cleanliness. Well, finally, the technology can be used also for construction monitoring. So for construction monitoring, for large construction, I will fly with helicopter or aircraft. For a smaller construction, I will use a drone fitted with the LiDAR equipment, and the construction site can be mapped. So how the changes are occurring in the construction site, that can be monitored, that can be mapped. Well, thank you very much. So if at all